Maybe I'll make this large. Oh, it is already larger. Okay. So that would be, that's how we draw our terminal arm, connecting 0, 0, and the point 3, 4. Okay. Now if I asked you to find, it says draw the terminal arm that passes through this point and determine its length. How could we find its length? Kind of gave you some hints already. Let's see here. Yeah? Jamie? You can. We can make a right triangle here. What would be the height? 4. And the base is 3. But so we can use Pythagorean theorem. We know c squared equals a squared plus b squared. C squared equals 3 squared plus 4 squared. Now, some of you might already know the answer if you know this type of triangle. It's called a 3, 4, 5 triangle. So if you ever are working in, I don't know, construction, you're framing a house one day, one thing they teach you in trade school is if you want to know if a wall, say, is 90 degrees with the ground, you're putting up a wall, you want to make sure it's a proper 90-degree perpendicular. What you would actually do, or even if on the floor you're building walls and you're trying to like put together a wall. So if you're building, right, you're putting the base down on the concrete, you measure 3, you measure 4, and then you make a tick. The distance, if it's 5, perfectly 5, then you know you have a perfect 90-degree angle, right? That's used all the time if you're like a framer or you're working construction. So that 3, 4, 5 triangle has it's such a great application. We can check to see if something's a right triangle as long as we make a tick. So we measure here 3, we measure on this part of the wall 4, and then measure that distance, it should be 5. Okay. So that's my cheesy explanation. Draw the following angles in center position given point x, y. Determine the length. So what quadrant would this be in? 2. So again, it's connecting with the origin. Make a right triangle. So x and y can be positive or negative, right? So this has a negative x and a positive y. What about your length of your terminal arm? Can the terminal arm be a negative? Well, let's look at the formula for Pythagorean. No matter what, if it's a positive or a negative squared, when we square root, we're always going to get the positive square root. We're not going to get plus or minus. We always use our hypotenuse, or also we're going to call it the radius, is always positive. Okay, so x and y can be negative, but when we solve for the length of the terminal arm, it's a distance, and a distance is always, or a length is always positive. Okay, that length. So we're never going to have our radius. The reason why I call it a radius is when we think of our terminal arm, right, it's going around in a circle. So it basically forms a circle when it does one full rotation, and so that distance, right, from the center to the outer circle is our radius, right? Makes sense? So that's why we often, because trigonometry is very, very tied to actual circles. And you're going to see that as you move into Math 30 especially, how a circle and the trig ratios are very much tied together. So not just triangles. Okay, so find the distance, we're going to use Pythagorean. So I'm going to actually call this r now instead of, just to get in the habit. So instead, we can say r squared is equal to x squared plus y squared instead of c squared equals a squared plus b squared. It's the same thing, but let's get used to using x, y, and r now instead of opposite, adjacent, c, a, and b. So r is a square root of negative 2 squared plus 3 squared. What happens when you square a negative? Positive.
We lose marks on the next time we use a squared plus b squared.
No, you wouldn't lose marks if you, but I do want to get you used to seeing it, so when it comes up, you're like, oh, I've seen it both ways, so I'm comfortable with it. Yeah, but you would never use, I'd never dock you marks if you use Pythagorean basic formula. Heck, I'm just happy that you're doing it right. T squared, negative 2 squared is 4 plus 9. What does that equal? 13? Now, can we actually square root 13 and get a whole number? No, it's irrational. So what we're going to do is we're actually going to leave it, because we want to leave it as an exact value, we're going to leave that as root 13. We can't simplify root 13 because if we think of the factors of 13, well, it's a prime number, 1 in 13. There is no perfect squares that actually is a factor of 13. What are our perfect squares, guys? 1, then 4, then 9, 16, 36, 49, right? These are, and so forth. These are our perfect squares. So only if we look at the number inside the radical, which is called our radicand, and we look at the radicand and we see, hey, one of these perfect squares is a factor of that number, can be divided into that number, then we actually have to simplify it. In this case, we can't, so we leave it as root 13. So let's try the next guy. Which quadrant is he in? 3. So negative 5, and y is negative 1. So why don't you go ahead and solve for the radius, or your hypotenuse. So when you type it in your calculator, don't type in the square root symbol. You just want to type in the squares. And you always have to put your square, if it's a negative, you have to put in brackets when you square it. Let me detach this so you can actually see it. So if I was typing that in, I'd be typing in negative 1 squared plus bracket. The negative has to be in brackets, or else your calculator will make it come out as a negative, which we don't want. Okay, so 26, root 26. Will a perfect square, is there any perfect squares that will divide into 26? Will 4 or 16 or 9 go into 26? No? So it's fully simplified. That's it. We leave it as root 26. Okay, the last one, what quadrant is he in? 1, 2, 3, or 4? 4. We label our x and our y. Let's find our radius. What do you get for your radicand? So radicand's the number inside the radical. Where's that? Okay. 20. Because you have 16 plus 4, right? When you square 2, it becomes a positive. Make sure it's in brackets in your calculator. 16 plus 4 is 20. Can we simplify that radical? Is there a perfect square that will go into 20? 4 does. Yeah, 4 is a factor. So 4 times what is 20? 5. So we're going to write that as root 4 times root 5. Those are equivalent. So 20 we can write as root 4 times root 5. It multiplies radicals with radicals. And the last we're going to do is actually square root the number we can square root. What's the square root of 4? 2. So that becomes my coefficient. That's 2 root 5. So you should get 2 root 5. All right? Easily, you can check to make sure you simplified that. You just type in root 20 in your calculator, type in 2 root 5. They should equal the same decimal, and then we're good. All right. To get full marks on an exam, you'd have to fully simplify. Yeah. That you will lose marks if you don't fully simplify your radicals. Okay? I know, this is where it's like all coming together, all these different skills you have to remember. All right, let's try another one, but this time we're going to make it a little different. So it says the point, and this is what we're going to actually be doing in this unit. The point -8 and 15 lies on the terminal arm of an angle theta in standard position. Determine the exact trig ratios for sine, cos, and tan theta. Okay, so let's start with drawing this. What quadrant is it in? Quadrant 2. Let's do a rough sketch. And then let's draw our right triangle. We always, again, use the bow tie, use with the x-axis. Okay. Now this angle theta, is that our rotation angle or our reference angle? The one that's made with the x-axis and the terminal arm? This angle here. That's what we call the reference angle. Yeah. Okay. So, what's the x value? -8. Y is 15. Now it wants us to find the ratios for sine, cos, and tan. Sine theta, cos theta, and tan theta. Now, remember we used SOHCAHTOA in the past? On your formula sheet, it doesn't show up like that. If you look on your formula sheet, which I can pull open if you want. Give me a sec. Oops. Okay, type in cos of 0 and sine of 0. So let's check that. Sine of 0 degrees, 0. Cos of 0, 1. Now, obviously, we could just type these in right now and figure out these ratios, but we're going to have to work backwards in the future. If we're given the ratio, we're going to have to figure out which angle it is. And that's where using this x over r is going to be really helpful, or y over r. Tan of 0 is the same thing as opposite over adjacent, or y over x. Y is 0. X is 1. 0 divided by 1 is 0. Is that true when you type that in? Tan of 0. Does that give you 0? Yes. Good. Okay, let's try 90 degrees. So sine is, remember sine is y over r. So when we do 90 degrees, y is 1 divided by our radius of 1 gives you 1. 1 over 1. Cos of 0, or sorry, cos of 90 degrees is going to be now your cos is x, which is 0 over 1, which is 0. Now here's a fun one. Tan. At 90 degrees, if we're doing y over x, what's our y value? 1. What's our x value? 0. Can you divide by 0? No. So we say does not exist. So type in tan of 90 degrees and see what your calculator tells you. It's what we call it says domain. Go to. Quit. Right? It's an error. It's undefined. Another word is undefined. It does not exist. Okay, if you type in tan of 90. So let's fill in the rest of these really quickly. 180. Y over r, so y is -1 over 1 is -1. Oh, sorry, 180. Y is 0. 0 over 1 is 0. Cos is x over r. X is -1 divided by 1 gives -1. And then tan, y over x, so 0 over -1 is 0. And then last is 270. Sine is y over r, so -1 over 1 is -1. Cos of 270, cos is x over r. X is 0 over 1 is 0. And then last, tan of 270, tan is y over x. Negative 1 over 0 is what? Does not exist, undefined. Okay. So that's going to be really important when you're trying to actually find the ratios of those angles. You can type them in your calculator, yes. However, when we have to go backwards, when you're given the ratio and you have to figure out the angle, it's not as simple as just typing in your calculator. We're going to have to use that concept of y over r, x over r, or y over x. Okay? All right, so the homework for this assignment, it actually is finished here. Page 96 to 99, numbers 3, 5, 8, and 11. So, I don't know what to do.